Hi guys, this is third lecture of electrostatic. Electric field lines, electric line of forces are field lines, all are basically same thing. But before you watch this video, first you revise that electric field concept, otherwise you cannot understand this one. So first you revise electric field concept and after that you can watch this video. Now, what is electric field lines? It's written over here, it's a hypothetical line to represent electric field. See, if any region, like this one is one region, this region have a electric field. So, if electric field intensity increasing, decreasing, we cannot see any change in this region. For example, electric field intensity increasing, I put one charge over here, more force will work. Now, electric field intensity decreasing, and I put one charge over here, less force will work. But by looking at this region, we cannot see that electric field changing or not. We need some lines to represent that. And whatever line represent that intensity of that field, strength of that field, that is called electric line of forces, or as simply field lines, or as electric field lines. Means to represent electric field, we need number of line. For example, one more example I give. Just look at this region. This region have a electric field, and we don't know what's the intensity of electric field. If intensity of that electric field is increasing, in that case, that line will be closely packed. And if intensity is decreasing, that line will be loosely packed. Means there will be gap. So using this line, we can represent the intensity of electric field. It's increasing or decreasing. So basically, by definition, we can say it's a hypothetical line to represent electric field. Electric field lines are hypothetical line to represent electric field. Now, these lines have some property. 5-6 properties are there. I wrote this 5-6 property over here. Once you can read this all property, and one by one I'll explain over here what does it mean, like what property meaning is there. Now, first property, if you look at this, emerge from positive charge and end at negative, or else terminate at negative. What's the meaning of this one? Let's say this one is one positive charge and this one is one negative charge. Now, electric field line, according to this first property, the electric field line always emerges from positive charge. It means always start from positive charge and it will end at negative charge. Means if I want to make electric field lines, it will be like this. Will be like this. If both are positive charge, then it will be like this one only. It will emerge from both charges like this, and both negative charge, in that case it will terminate on both charges. This is negative, this one also negative, so it will terminate on both charges. It means it emerges from positive charge and end at negative charge. So that is meaning of first statement. Electric field lines always emerge from positive one and end at negative one. Now, this is the second property, number of line directly proportional to charge. What does it mean? Means more charge will be there, more number of line, less charge, less number of line. For example, this one is 1 plus q charge and this one is minus q charge. So if two number of line emerge from positive charge, how many number of line and over here? 2 number of line, because what's the ratio of these charges? 1:1. Only magnitude I am talking about. This one is q, this one is also q, magnitude wise q by q, that will be equal to 1. Now let's say this charge is 2q and this one is minus q. In that case, if 4 number of line emerge from this one, only 2 lines will end over here. Why? Because what's the ratio of these two charges? 2:1. Means if 8 will emerge, 4 will end. 6 will emerge, 3 will end. So what will be diagram over here? What will be electric field lines diagram over here? It will be like this. 4 will emerge and 2 will end. See how many number of line emerging from here? 4. And how many line ending over here? 2. Now where these two lines are going? At infinity. These lines are going at infinity. Now if I make this diagram, this one is minus 2q. Okay, this one is q. And this one will be minus 2q. In that case, what will be diagram? See, this 2 number of line, we need 4, so they are coming from infinity. See, from this plus q charge, only 2 number of line emerging, and at minus 2q, 4 number of line ending. So this is meaning of this property second. So two property we have done. First one emerge from positive and at negative. Second one, number of line directly proportional to charges. And third one, they won't intersect. This property I won't explain. We already know this one in 10th grade we have done. Electric field line does not intersect. What's the reason for that? They does not intersect because if they intersect, there will be two different directions. So everyone know that in 10th grade we have done. If something intersect, that will have a two direction. At one point, electric field cannot have a two direction. That's why they won't intersect. So 3 points done. Now, next point, tangent on electric field line. EFL means electric field lines. Tangent on electric field line represent direction of electric field. So if these are electric field lines, this one is charge q and this one is minus q. These are electric field lines. So at any point, if I ask what will be direction of electric field, let's say this point is P1, this point is P2, this point is P3. So at this point, P1, I ask what's direction of electric field. So I draw tangent. So this will be direction of electric field. At this point, if I ask what is the direction of electric field, tangent on that. At this point, what is the direction of electric field, tangent on that. It means at any point, if I ask what's the direction of electric field, if electric field lines are given, at any point, if I ask what's the direction of electric field, so just you have to draw tangent. Tangent on that point itself represent direction of a electric field. So this one is fourth property. Now fifth one, if you see, inside conductor electric field lines are zero. Electric field lines are zero means inside conductor they are absent because there is no electric field inside conductor surface, any conducting material. That's why that electric field lines are not there. Means if this is conducting surface, so line will start from here and end. This is one conducting solid state. This is electric field line. See, it enter at this point and emerge from this one, and inside it's absent. And one more thing, on the surface of conductor strike at angle 90 degree, means that angle should be 90 degree. This angle should be also 90 degree. So this one is fifth property, and this property is what? Inside conductor they must be absent, and on the surface of conductor strike at angle 90 degree and emerge at angle 90 degree. Now next property of this one, it does not form closed loop. See, I already told you start from positive charge and end at negative charge, because it's ending at negative charge, so obviously it does not form closed loop. And we are talking about electrostatic electric field, means this one electric field. The electric fields are two types. Right now we are talking about electrostatic electric field. Electrostatic electric field does not form closed loop. So if we start from here, this diagram, see, starting from here and ending at this point, this is not closed loop. Closed loop means if it is like this loop is closed. See, arrow is going there and returning back. This loop is closed. This loop is not closed. Still it's a loop, but it's not a closed loop, because starting from here, ending at this point. This one also starting from here and ending at this point. So this does not form a closed loop. Now just do one thing using this property. Just for 1 or 2 minutes you can pause this video. Just I'll give one question. Pause this video. Try to answer that question. Obviously you forward that one, you can see the answer. Now using this all property, this 5-6 property, I am asking one question. And based on this property itself, we have to answer that question. Just see that question and pause that video, try to answer it. And obviously, if you are not able to answer it, forward that video, you can see the answer. Now, question is, this one is one solid conducting sphere. And these are 4 lines. These are 4 lines. This is center. These are 4 lines. Just you have to tell which one is electric field line. is the first line, this is second line, this one is third line, this one is fourth one, and this is solid conducting sphere. So there are 4 options. You can say 1, 2, 3, 4. Which one is electric field line? Just pause this video, try to answer it. Obviously forward this video and there will be answer. Okay. So I think this first one is not an electric field lines. Why? Because this angle is not 90 degree. This is conducting surface. This solid sphere is conducting surface. So if it is electric field line, that angle must be 90 degree, and this is not 90 degree. How we know it's not 90 degree? Because if something 90 degree on the solid sphere, that line must pass through the center. So anyway, if I extend, even if I extend this line, it won't pass through the center. It means what? This angle is not a 90 degree. So first one is not answer. It's a ruled out. First one is not answer. Now look at second one. This second line, it cannot be electric field lines. Why? Because if this one is electric field line, inside conductor it must be absent. So it's present inside this one. So that's why it's not electric field line. Now second also ruled out. Now look at third one. By same reason, third one also not answer, because this angle is 90 degree. It's fine, but inside it should be absent. There is a property inside conductor that electric field lines are not there, means they are absent. So but here look at this electric field lines there, it means this one is not answer. Now fourth one is right answer. So fourth one is right answer for this one. Thank you.